All right, so let's take a look at lesson 18, and we're going to start with part 2, be discriminating. And this is lesson 18 of unit 3. We were talking about the quadratic formula and complex numbers. So Kieran was using the quadratic formula to solve the equation x squared minus 12x plus 41 equals 0, and he wrote this. X equals 12 plus or minus the square root of 144 minus 164, all divided by 2. Now remember that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and so a is 1 in this case, b is negative 12, which I did not put a negative there, negative 12, and c is 41 because the entire equation is set equal to 0. If it's not set equal to 0, you can't use the quadratic formula in that way. So make sure the whole problem is set equal to 0, and then you have the correct a, b, and c. All right, so he noticed that the number inside the square root is negative because when you subtract 144 minus 164, you get a negative. And so he says this equation doesn't have any solutions. Do you agree with him? And I would say yes, because in order for a number to be real, it can't be the square root of a negative. So yes. It doesn't have any, well, I don't know that I agree because he said it doesn't have any solutions. I would say it doesn't have any real solutions, but it does have non-real, right? It doesn't have any real solutions, right? Because before we talked about imaginary numbers, we would have said it has no solution, right? But now we recognize that there are non-real numbers, and so it does have non-real solutions. Okay, so it's a little bit different than what we did before when we didn't know about imaginary numbers. So we're going to write square root of negative 20 as an imaginary number. So remember, that's the same thing as the square root of negative 1 times the square root of 20. And so that square root of negative 1 is I, and then square root of 20. So you could leave it like that. Or if you want to break that down even further, you could say, okay, well, negative 20 is the square root of 4, which is a perfect square, times the square root of 5. So then you can take the square root of 4, and you end up with 2i times the square root of 5. So you could give that. Although if you give I square root of 20, that is perfectly fine. All right, and then number 3, solve the equation 3x squared minus 10 plus 50 equals 0. And then plot the solution. So we're going to use the quadratic formula. So here we have a is 3, b is negative 10, and c is 50. And again, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I do want to point out that this inside is called the discriminant. You may need to know that at some point. So, all right. And you don't have to memorize this formula. It's on the formula sheet, the reference sheet that you'll have for MCAP. So no need to memorize that. All right, so let's take a look at when we plug in the numbers. So x equals positive 10 because it's negative 10, plus or minus the square root of negative 10 quantity squared is 100, minus 4 times 3, which is 12, times 50, which is 600, all over 2 times 3, which is 6. So we have x equals 10 plus or minus the square root of negative 500, all over 6. and excuse me. So we have 10 over 6 plus or minus the square root of, well, actually, you know what? We're going to factor out that I. So that's the same thing as -1. So the square root of -1 is I, times the square root of 500 over 6. All right, so that, we can simplify that to 5/3 plus or minus. Now, the square root of I, that's going to be in, or I'm sorry, not the square root of I, the square root of 500 is going to be in between 22 and 23. Over 6. Okay, and so we know that the 5/3, that's our real part, so that's our horizontal when we graph. And then this part is our non-real or imaginary, and that's the vertical. All right, and that's somewhere between 22 and 23. So when we graph the real part, we're going to the right 5/3, so that's about 2/3 of the, well, it is 2/3 of the way from 1 to 2, right? Because 6/3 would be 2. Well, I don't really want to plot that point there. I'm just going that direction, that far. And then for the vertical, we are going to go, we're going to go up. Let's see, if it was between 22 and 23, it's not quite 4, because if it was 24 divided by 6, then it would be 4. So we're going to go up to a little less than 4. So it's going to be somewhere around there. And that's when you add, right? And then when we do the subtraction, we're going to go down. And so this one is 5/3 minus the square root, I, square root of 500 over 6. And this one is 5/3, and then I square root of 500, and that's the positive one. No, we don't really need those commas, sorry. It's not really an ordered pair. All right. Okay, so now let's take a look at the next piece. 18.3, solving all kinds of quadratics. All right, so this is normally a partner activity, so we'll just do this together. All right, so we are going to solve each quadratic equation and then see if we get the same answer. All right. Excuse me. All right, so if we use the quadratic formula for the first one in column A, we would have x equals -4, so that's +4, plus or minus -4 quantity squared is 16 minus 4 times a, actually I'm going to, 4 times a, which is 1, so 4 times 1 is 4, times -4, that's -16, so it's minus a -16, all over 2 times a, which is 2. So x equals 4 plus or minus the square root of 32, all over 2. So x equals 4 plus or minus. Now, that 32 can break apart into square root of 16 and the square root of 2. And the square root of 16 is 4. And that 2 stays under the radical, and that's all divided by 2. So x equals 2 plus or minus 2 square root of 2, because you would break apart and put 4 over 2 and then 4 square root of 2 over 2. All right, so then if we were to do the square root of both sides for partner B, we would have x minus 2 equals plus or minus the square root of 8. And so then x equals 2 plus or minus the square root of 8. But again, 8 can break apart into the square root of 4 times the square root of 2, So x equals 2 plus or minus 2 square root of 2. And that is the same answer. All right, and so then you can work through all the rest of them and see if you get the same answer. So I will just give you what those answers are. We'll say this was 1. We'll give that one a 2. So number 2, you would end up with y equals 2 plus or minus I square root of 8. Or you could say y equals 2 plus or minus 2I square root of 2. Let's see, the third one, you end up with z equals -3/2 plus or minus the square root of 29 over 2 times I. And again, you can use quadratic formula for these. For some of them, you can just take the square root of both sides because they've already, it's kind of like the process of completing the square. And number 4, you end up with w equals -3/2 plus or minus the square root of 29 over 2. So notice that one doesn't even have an I in it. So numbers 1 and 4 don't have I's, but 2 and 3 do. They're very similar to the other problems, but they do not have, the 1 and 4 don't have imaginary numbers, and 2 and 3 do. And then number 5, t is equal to 5/2. And that was a double root. When you solve that one, you get the same answer twice. So that is why there's only one answer there. All right. And that is using quadratic formula with imaginary numbers or complex numbers.